All right, so 8.4 day 1, we're going to use law of cosines to find missing sides in or angles in a triangle. So missing measures, oblique triangle for side, angle, side, or side, side, side. If you recall, law of sines was angle, angle, side, or angle, side, angle. These are two other scenarios of given information, two sides and the angle between, or all three sides. This is the law of cosines. I'll give you a moment here. Just pause the video, copy those down. 3, 2, 1. All right, so here is the law of cosines. It says use it given side, angle, side, or side, side, side. So we know all three sides, or let's say side, angle, side A, side C, and angle B maybe, or side B, side C, and angle A. So two sides and the angle between. It says never use law of sines to find the biggest angle, always use law of cosines. So if I'm looking at this picture, B is obtuse in the picture, that would tell me B is the longest side. But in general, if you know all three angles, the biggest side is opposite the biggest angle. If you know all three sides, the biggest side is opposite the biggest angle. So either way you look at it, you should be able to establish what the biggest side is, what the biggest angle is from the information when necessary. The law of sines is really the Pythagorean theorem. Look, a squared equals b squared plus c squared, b squared equals a squared plus c squared, c squared equals a squared plus b squared. That's the Pythagorean theorem look to it, but you're subtracting this extra piece in every case. The extra piece is simply minus 2 times the product of the two pieces here that aren't this side and the cosine of the angle opposite that side. So if I'm dealing with side A, I want to deal with angle A. So this side and this angle need to match. Everything else is about the other two sides, B and C here squared, B and C here multiplied by -2. All three of these things are being multiplied, I should say all four of these things, the 2 and the B and the C and the cosine of A are all being multiplied together. That's a single term. So, if we put this into practice, here's an example problem. What is BC to the nearest tenth? Okay, so for ABC, what is BC to the nearest tenth? Then use the law of sines to find measure of angle B. So even though we're in the law of cosines chapter, we're going to use the law of sines once we get to the point we can. Law of sines, hopefully you guys recognize it's not very hard to use. So when we get to a point where we can use the law of sines, we should. But given this problem, I've got a side, I've got an angle, I've got a side. So this is side, angle, side setup. And since it's side, angle, side, I have to use law of cosines to begin with. It says, what is BC to the nearest tenth? I'm just going to call BC X, just to give it a name. And you'll notice that X, the side we don't know, is opposite 57 degrees. All right, so again, when you're doing law of cosines, I'm going to go back here real quick. We need to establish a relationship between a side and the angle opposite. So since we only know the single angle, if we know the single angle, we got this side is going to go opposite it. So we only know this angle, that's going to go opposite. So, once I establish I'm using that angle, I'm going to have x squared equals, and I'm going to have something plus something minus something. But the cosine part here, I'm going to put 57 degrees. All right, so again, you can establish that once you've established this angle is one I've got to use, that side's opposite the angle, those two things go there. The other two things are 8 and 10. 8 squared goes here, 10 squared goes here, 2 times 8 times 10 goes here. Okay, one part people tend to mess up on the law of sine, the law of cosines here is this 2. That's just part of the formula. It's there every single time. The 8 and the 10 come from here. So 8 and 10 are the sides in the triangle, 8 squared and 8, 10 squared and 10, all this stuff being multiplied together. Once you write it all out, everything on the right-hand side of this is simply a numerical expression. This is x squared equals. I'm going to evaluate that. I'm going to do it in pieces here, though, just to kind of reinforce where things are coming from. So, if I type in cosine of 57, that equals 0.5446. Again, I'm using the law of cosines, that's why I did cosine. 8 squared is 64, 10 squared is 100. This, and this, that's all being multiplied together, so I need to multiply all that together. So I'm going to type in 2 times 8 times 10 times 0.5446. That gets me 87.136. It says minus, right? So minus that product. So minus 87.136. Sometimes cosine is negative. If that's negative, negative times negative makes a positive. Right? In this case, it's negative, or it's minus because that's a positive number. Minus all that stuff just makes minus that number. Then I just have to type in 64 plus 100 minus 87.136. That tells me x squared equals 76.864. And finally, if x squared equals that, x must equal the square root of 76.864. That comes out to 8.76. Now the question said to find BC to the nearest tenth. BC is x, right? So I'm going to write BC equals, I'm going to write 8.8. Right, so I'm going to use the 8.76 on my picture here though, because 8.76 is a little bit more accurate, a little bit more correct. Now, the second thing it asks me to do once I've found out what BC is, it says use the law of sines to find measure of angle B. So let's take a look at how that looks. If I want to find the measure of angle B, I've got this side is opposite this angle I want to know. So that's going to be 8 over the sine of B. And then I know this side and I know this angle, those are opposite one another. Okay. Now looking at the three sides, 8, 8.76, and 10, I know for a fact angle B is smaller than angle C because 8 is smaller than 10. Again, going back here, it says never use law of sines to find the biggest angle. Okay, so I'm telling you to find B next, but in essence, if I said find everything that's missing in this triangle, you would hopefully know to find B next because B is smaller than C and I'm using law of sines. If I do law of sines like I always do, it's going to be 8 over the sine of B equals 8.76 over the sine of 57 degrees. All right. Once again, my calculator knows the sine of 57, so I'm going to ask it. Sine 57 equals, it's 0.8387. So I'm going to throw that out, put 0.8387 there. Then I'm going to cross multiply. So 8.76 times sine of B equals 8 times 0.8387. That's 6.7096. So that means sine of B equals, so I'm going to do 6.7096 divided by 8.76. And that gets me 0.7659. Now, all this work here has led us to this point. So again, this is the law of sines in action. We don't know what B, angle B is, so it's 8 over sine of an unknown angle, 8.76 over sine of a known angle, so we had a number there. I cross multiply. I get sine of B equals, but I don't know what B equals. I'm going to do B equals inverse sine of 0.7659. And again, we've already seen this before on section 8.2. We did inverse trig functions to find angles. Some of you didn't use the inverse button on your calculator. I'm going to bring up the Google calculator here just to show you how that's being used here. So just find my 0.7659. So I want to inverse sine. So I hit inverse, and you notice it says sine -1. You can see that degrees is lit up, which means it's going to give me the answer in degrees. 0.7659, if my memory serves me right, is what we're looking for. That tells me the angle is 49.987. 49.987. Okay. Now, to the nearest tenth, this was to the nearest tenth, so I'm going to say this is nearest tenth also. The measure of angle B equals. Now, if I round that to the nearest tenth, this 8 makes that 9 go up to a 0, which makes this 9 go 1 bigger to a 0, which makes that 4 go up 1 bigger to 50. So 50.0 is the round to the nearest 10th answer for angle B. And then it says find angle C. It doesn't tell you how to find angle C, but now that we know angle B is 50, angle A, 57, plus angle B, 50, makes 107 degrees. Angle C plus 107 degrees should equal 180 degrees. Move 107 over. We get measure of angle C is equal to 73.0 degrees. And notice I'm putting the point zeros there because these are rounded values. This is the more accurate value for B. I rounded it to 50.0, so I'm going to write 50.0 just to let the reader of the problem know that this is not exactly 50 degrees, it's a rounded to answer. So keep that in mind when you are rounding, that you do put the decimal place in there.